This is Algebra 2, Intro to Transformations. Today in class, we did a hands-on lesson. We didn't really take notes. So if you were absent or if you just want to revisit what we did in class, I've made a couple Desmos graphs to look at what we did in class. So first of all, we are doing absolute value. So we look at absolute value by itself. An absolute value is a V shape. No matter what I do to it, it's always going to be a V shape. So this black absolute value graph is the absolute value with no transformations whatsoever. Transformations would be something that would change this V shape to be, it's going to still be a V shape. It's just going to be smaller or bigger or skinnier or wider or up or down or left or right. It's going to move it around. It could even rotate it, but we're not going to do rotations in here. So what I'm going to do is I'm going to show you some different graphs that we did in class today. So we did absolute value of x plus 2. We did absolute value of x minus 4. Negative absolute value of x. So I'm going to turn that purple one off and then on. And you can see from the black one to the purple one what it looks like when we have a negative in front. And then what we did was we took negative absolute value and we moved it other places, like negative absolute value of x minus 3. And so it has that upside down V shape, but it's also moved further away from the center, that origin at 0, 0. We talked about this point being very important. This is the vertex, V-E-R-T-E-X, vertex. It's a very important point because it's part of both sides of the absolute value. There's like two lines that come together to make this V, but this vertex kind of connects both of them, kind of controls both of them. We also did something like 2 absolute value of x. And with 2 absolute value of x, we're doubling the absolute value, so it's getting bigger faster, and I'll show you that more on my other Desmos screen. And then f of x equals 1/2 absolute value of x. This one's a little bit wider. So I'm going to talk a little bit more in detail about these different graphs on this screen. So what we did in class today is each person was an x value. So we had somebody at 0, we had somebody at 1, 2, 3, -1, -2, -3. There were a couple 4s in my bigger classes. So each person had an x value, and we put that x value into the absolute value of x, and we ended up with these red points. So I had people standing at these red points. Okay, and then what we did next is we used transformations. So I've got this k value right here, and the k can represent any number. And then right here, I have something called a slider. Right now, k is 0. So there's nothing happening here. I also have an a value. My a value currently is 1. And if I multiply 1 times anything, then it doesn't change the value. So 0, adding 0 doesn't change it. Multiplying by 1 doesn't change it. So there's no transformations done. But what I'm going to do is I'm going to take this k value and I'm going to add on numbers. So this is not going to just add on instantly. It's just going to kind of slide slowly. So you can see if I make k a bigger number, the transformation is taking this graph up that amount. So I'm going to go back to where it was at 0. If I add k, any number whatsoever, if I'm adding a number, it's taking the graph up. So our blue one is the transformed equation. The black one is the original. And I left the black one there just so you can see and compare it to the original. Now let's say instead of adding a number, I subtract a number. How I'm going to subtract a number, I still have a plus here, but how I'm going to subtract a number is I'm just going to use negative numbers instead. So I'm going to take this number and I'm going to go negative. And I should move the screen a little bit for you. As I increase that negative number and it's going more and more negative, you can see that this V shape is just sliding down. The word slide we're going to use as, let's see if I can, a note. Let me put a note in there. The word is going to be translate. So we're going to translate this graph either up, down, left, or right. So far, I've showed you that if we add on a number bigger than 0, it's going to slide it or translate up. If we add on a negative number, or you might see it as subtraction, it's going to translate down. So that's the first thing that we practiced with today. The next thing that we practiced with was something in this A spot. Now, I don't have it set up right. Hold on a second. Go. Okay. The second thing that we practiced was in this A spot right here in the equation where there's an A spot, we looked at different numbers being there. We looked at it just being a -1. So this is going to slide, but I want to do it kind of fast because I'm not looking at all the numbers in between right now. We're just going to look at -1. So I'm going to go there. Okay, so if we have our A value being a -1, it reflects the graph. It was up here, and now it's a reflection down here. You notice that the vertex, the very important vertex, does not change with the reflection. So again, if A is -1, I'll add a note here. Okay, so we're talking about it reflects the graph down. So if A is -1, it reflects the graph down. So remember, if I do have a negative in front here, just it's going to change the black one, but I'll fix it in a moment. If I do have a negative in front here, that's the same thing as multiplying by -1. So multiplying by -1, same thing as just having a negative sign here. So when we have our original black graph, what we do is we take all of the y values. Let me go. Let me take this one back to 1. We take all of our y values, which are the ordered pairs, and inside of this absolute value, the y values are all positive. That's what absolute value does. So we take all of those y values, and what we do instead is we put a negative in front. So if we put a negative in front, that takes all the y values and changes them into negative of their same value. So here and here, we still have the same x value, but our y values changed from positive to negative. Right here at 1, -1, we still have the same x value as the original, but our y values changed. So that's what a negative will do. And then what we also did is we had a negative absolute value of x. So A right now is -1, and we took our k value and changed that. So you can see if I have, k plus 4, it's going to move it up 4, but it's also flipped down. Or if I have k minus 3, it flipped it down and it moved it down 3. So put k back at 0. And I'm going to take A and move it back to 1. Okay, so the third thing that we did was we looked at A values when they weren't 1 or -1. We looked at A values that weren't 1 or -1. So I'm going to just move the screen a little bit, and I'm going to have you look and see the points, the red points. Look at how they do not move side to side at all. The red points are just going to move up and down, but the overall V shape is going to appear to change. So I'm going to make this A value bigger. And if you're looking carefully, those red values are not going left or right. They're still, X is -1, X is -2, X is -3. They're still staying at those X values. But the Y values are getting bigger and bigger and bigger and bigger and bigger. What's happening? Oops, I didn't go to that one yet. If I multiply anything by a number bigger than 1, sorry, there we go. Here's 1. If I multiply anything by a number bigger than 1, it's going to get bigger. So if I'm taking these Y values, I'm not multiplying the X's are what I put into the absolute value of X. The Y values are what I'm multiplying A by. Okay, if I take absolute value of X, multiply them by whatever A value, if it's more than 1, it's going to get bigger. So that's the third thing we talked about. Let me put a note here. So we said if we multiply a number bigger than 1, Y values, and we use the word stretch. Got bigger. This is called a vertical stretch. I made sure to include the words vertical with vertical stretch, with not just saying stretch, but I need to say vertical stretch because eventually we're going to have horizontal stretch as well. We're not going to do that yet, but we're going to eventually. So we need to know the difference between a vertical stretch and a horizontal stretch. So this one is a vertical stretch. Our horizontals didn't change. They are still at 1, -1, 2, 3. Our horizontals didn't change. It was the verticals that changed. Okay. So now I'm going to go back to this A value. I'm going to put it at 1. And now I'm going to make it smaller. So I'm going to take this and this is just counting in tenths. Oh no, it's counting in hundredths maybe. Anyway, it's going to make it smaller and smaller and smaller. And we did 1/2 as one of our transformations in class. We did A was 1/2. Oops, I didn't mean to move this. Hold on. I meant to move that. So we did our A value. This value right in front was 1/2. And so what we can look at is our X values are the same, but we look at our Y values. And so if our Y value was -1, 1, now it's 1/2. This one, the Y value was -2, 2. The Y value was a 2, but now it's 1. If I put in 3, I now have 1/2. So it's taking half of the Y values. And because it's going half as large, you're going to see that this graph doesn't rise up as fast. It's like a lazy graph. It doesn't go up as quick. It looks wider. This graph is the result of a vertical shrink. We talked about what makes a number a vertical shrink. So if we multiply, don't know why. Oh, I didn't make it a note. Hold on a second. If we multiply by a number that is bigger than 0 but less than 1, we get a vertical shrink. Now, I had to put that bigger than 0. Let's see what happens if we're actually multiplying by something that's not bigger than 0. So here I'm multiplying by anything less than 1, and you can see that this graph is shrinking down, but eventually I get to A equals 0. And as soon as I get to A equals 0, we do not have a V shape anymore. So this is not an absolute value graph. If I go further, it is a shrink, but we now have a negative number, and we already talked about how the negative, if A is negative, it reflects the graph down. So that's a completely separate transformation than a vertical shrink. Oops. Oh, that's a stretch. Vertical shrink. So vertical shrink and a negative number are two separate transformations. So I can still play with this. I can go back to, here's my positives. We've got a vertical shrink, but it's facing up. Or if I go lower than 0, now I've got a vertical shrink, but it's also reflected down. Now, once I go down to -1, there is no shrink or stretch. It's exactly the same graph reflected down. If I go past -1, so I still have that reflection, but now the graph is stretching vertically. It just happens to be stretching vertically down rather than vertically up. So the negative sign only affects if it's up or down. The number itself, if it's bigger than 1, is a stretch. If it's between 0 and 1, it's a shrink. That's basically what we learned today, only we did it hands-on instead of just writing down notes. We will continue to do some more hands-on over the next few days so that we can learn more transformations, like all the horizontals. But in the meantime, you need to know these verticals.